All right. I think everybody has joined us. Welcome, everybody. Thanks for spending part of your evening tonight with us to talk about the New River Innovation Challenge. My name is Shannon Baker, and I'm the project director with the Portland's flood protection team at Waterfront Toronto for the parks and public realm. We'll begin tonight acknowledging the land upon which we're undertaking our revitalization efforts. That land is part of the traditional territories of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to diverse First Nations, Inuit, Métis peoples. We acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. And if you are not in Toronto right now, we ask that you take a moment to acknowledge if you know the traditional territory upon which you are located. A little bit of housekeeping tonight. Obviously we're in Microsoft Teams. You've all made it here. We are recording it and we'll be posting the meeting to YouTube, so that it'll be accessible on our YouTube channel following this. Only the presentations and the presenters will be visible in the recorded version. We ask that you please keep your camera off during the main presentation and feel free to turn your camera on during the breakout sessions or the networking session when we get to that. We will be taking questions. So throughout the presentations, if a question arises and you have something you'd like to ask, please use the chat for that. And then once we get through the presentations, I will be going through the questions and fielding them for our panel today, so that they can be answered. We will also be recording all of those questions and posting them online as well, so they'll be available for your reference in the future as we move forward. So this evening, we'll go through a bit of an overview about the challenge, and then we'll have presentations from Jonathan Kusa, President and CEO, and Marty Melchor, Principal Ecologist and Fisheries Biologist with Interfluve, as well as Angela Wallace, who's a Senior Project Manager, Aquatic Monitoring and Management with the Toronto and Region Conservation Authority. Following the presentations, we will open it up for a question and answer session with you. And then we will have an optional networking session following that. That's an opportunity for you to just have a little bit more informal chat with some of us and with some of your peers who have joined us today, so that you can make connections and form teams if that's something that you're interested in. No obligation to stay for that session. It's completely optional. And as I said, we won't be recording that portion of the evening tonight. So a little bit about the New River Innovation Challenge. If you haven't had a chance to dive in to a lot of the details tonight, we're focusing obviously on the water and aquatic species. But we have had some other sessions focusing on the park design as well as earthworks and geotechnical. And again, all of those are available to you if you didn't have a chance to join those sessions on the YouTube channel. We're inviting innovators such as yourselves to identify and or create new ways of broadening public knowledge about conservation science that's generated by PLFP. We have an obligation through the environmental assessment that was conducted for this project to gather scientific data and to measure the performance of this new river that we're creating at the Portlands. And so this innovation challenge, we think, is a really fabulous opportunity to engage some of you in that process and to really leverage that scientific data that we're collecting. So we're asking that the submitted ideas aim to collect and reveal and decode some of that scientific data that we're gathering in really compelling and appealing ways in order to help educate citizens about nature and encourage stewardship and sustainable development. And we're suggesting that this can be done through innovations in environmental data collection, platforms, methods, instruments, as well as data interpretation and representation. So the question, oh, sorry, Michaela, if you could just go back. Thanks. So the question that we're posing to you really is, how do we collect and share this environmental data from new ecosystems to incentivize conservation and behavior change in the wider community? And we've got a link there for you if you would like to refer to that website for updates and relevant dates in terms of the competition milestones. We're asking that you submit questions about the challenge to innovationchallenge@waterfronttoronto.ca by 11:59 on March the 25th. And the answers to the questions will be posted on our website by April the 12th. And the deadline to submit proposals is May the 7th. So with that, I think we will jump right into the presentations. We're excited tonight to hear from Jonathan, Marty, and Angela. And with that, I think, Marty, I'll pass it over to you to jump into your presentation. Thanks.
Okay, super. Thank you. Let's see. Are we looking at the slideshow now?
Yep.
The slide? Okay.
You're good, Marty. Thanks.
Okay, so thank you. So I'm going to talk just real briefly about the design, just a couple of slides, and then I'll get into kind of my wish list for monitoring. The way that we design, I think, has a little bit to do with development of the performance criteria and the design criteria, and that relates directly to monitoring. So it's worth talking about just a little bit. In this case, we're designing using a couple of different tools. One is analog-based design, where we looked at several different river mouths in the area and found analogs for design within those areas, and are applying some of the aspects of the topography, bathymetry, and habitat, et cetera, to the downriver design. And the second part of that equation then is analytical methods. So using hydraulic modeling, for instance, one-dimensional and two-dimensional modeling to look at river flows, flooding, sediment transport, and water flow in the area, and combining those two into a design. Now, when we start any kind of project, we start with the performance criteria. So basically, we ask, what do people want to see out of this project? And this project's been going for a long time, and the performance criteria have been really, really worked over many, many times, right? And when we came into the process, it was kind of a matter of just refining some of those performance criteria. And then our job as designers is to take those ideas and transmute them, I guess, change them into numerical design criteria, things that are measurable. And the best way to think about developing design criteria is to think about how we would monitor the site, and so success monitoring. And so your numerical design criteria can relate then directly to success monitoring. The performance criteria that Interfluid was concerned about have to do with relieving flooding impacts as a big constraint to the project. That's one of the main goals. But then within that, creating a facsimile of a river mouth. Historically, the river came down and did a hard left into Ashbridge's Marsh, but we can't really repeat that. We can't recreate that. We don't have all that space available. And so we have to create some sort of facsimile of that original condition. Create a long-term sustainable in-river habitat complexity. So Right now, there's not very much complexity in the Keating Channel, and we need to design that into the natural system so it's more like a natural system. Creating a stable river mouth. We're designing a static boundary here, so the river is not really going to be able to meander and move around like a natural river system would. So it's, again, a facsimile that grabs certain elements of the natural system. And then developing diverse plant and animal communities within that design. So the rest of the slides are really basically just my wish list, or our wish list. If we had unlimited funds and money was no object, these are the sorts of ideas that we always want to do on restoration projects, but we almost never get to do. And so the first thing has to do with hydraulics. There are some simple things like that we can do, just for instance, calibrating hydraulic models by looking at aerial photos and measuring flood elevations, etc. Now, the design channel, the natural channel part of the design, is comparatively larger in relation to what we normally think of as a channel forming flow. This Q1.5 to 2 year event, than the Duffins or the Rouge, mainly because we have to convey a certain amount of water. And so one of the things that's of interest to us is we've got sediment being removed upstream, but some sediment is going to be moving downstream as well. We're interested to see where that sediment goes and what its fate is through the natural channel. And we can do this in a lot of ways. We can take repeat channel surveys. You survey the as-built condition in multiple years. Measuring sediment movement in a variety of ways. Looking at sample grain size, for instance, on point bar, say, and seeing if that changes over time. Looking at velocities in the channel to see what we're getting for habitat and if it's matching kind of our estimates for velocity during low flow and at higher events as well. And then look, I think what's of interest to me is algal growth patterns, along the long profile in both the Keating channel and our natural channel, to see if there's any difference there. Bioengineering wise, so we're doing a lot of bioengineering here, reconstructing this whole valley and river banks and wetlands. And so there's a lot of dirt moving and a lot of stabilization of that material using biodegradable fabrics and plants. And so we're planning a lot of plans here. And so there's a warranty that the contractor has to follow for irrigation and replacement of plants that don't survive. But there are other things that can be done. We could look at plant success by type, plant success by species. So by type, I mean we've got potted stock going in, there's bare root stock going in, live stakes, and seed and plugs. So how are each one of those types doing in different situations? Looking at the root density, so the heart of bioengineering is really the roots grabbing hold of the soil and holding it in place. And so looking at how fast those plants are growing and the root density that's resulting from those plantings. And then looking at piping losses of soil, are we seeing any of that? And if so, where? Settling, we're doing a lot of compaction here, and there's tight controls over that, so we're not expecting settling, but just monitoring elevations and doing DEMs in sections. Fabric tensile strength, so we know what the laboratory tensile strength is. We have our own 30 years of experience with these fabrics, but there are new ones. There are some all biodegradable ones that we've used for years, but we've never really done any testing about how long they last in situ and what the changes in tensile strength are in some of those materials. This is a great opportunity to test some of that. And then the design life of large wood elements. So we're placing a lot of large wood in the river and the wetlands for habitat. And the submerged wood is, of course, going to last a long, long time. But some of the wood's going to be partially submerged, and some of it will be even less submerged than that. And so those have a definite design life if they're getting wet and dry or just out in the air. And so it's a good opportunity to monitor that and get some real data on loss of material over time for the different species. Post-flood monitoring, looking at the stability of bank and berm treatments. This kind of goes back to the one I just presented, but impacts to wetlands. So if you have a spring flood, say, and there's ice coming down, is there any impact from that ice or from the floods that come through? Bed material stability. Do our calculations of incipient motion size for channel bed material, for instance, match what's happening in life? Scour of habitat elements. So after a certain number of years, are we maintaining pool scour and maintaining our habitat, or are there areas that are filling in? And if so, why? And ice impacts to the shoreline treatments as well. So in the coves, for instance, in the northwest corner. Looking at wildlife as part of the urban ecology. So are animals using the spaces that we've built for them? Bat boxes, for instance, or chimney swift habitat, things like that. Are there animals that are coming in and making their own spaces? So otters and other things. Are there recreational impacts on animal behavior? Are we not seeing animals that we thought we maybe should be seeing? And how does the use of the space by humans impact those numbers? Turtle nesting design effectiveness. So we have some species like bats, for instance, and turtles where we're actually building specific habitat for them. So targeting those specific single species as well as communities. And then, amphibians, for instance, and shorebirds, are they using the large wood habitat that we placed out there for them? Birds. So again, are they using the spaces that we've provided? Are they using other spaces, making their own space? Are there differences in the wetland areas versus the river usage? So the greenway is a little more isolated, doesn't have as much recreational use adjacent to it. Is that being used by a different species? It's also a different shape. Flight paths for waterfowl, do we give them enough room to land and take off? We think we did, but what's observed versus what's predicted. And then predators, are we getting osprey out there? Are we getting marsh hawks and things like that? We developed a multi-level community out there. Cormorants, they're a concern. So their response to the project site will be interesting. And then piscivores, so are the fish coming in? Are the fishing birds using that habitat? Fish in stream, in river, and in wetlands too. So again, we're building spawning habitat in the wetlands, for instance. So our pumpkin seed and largemouth bass using that. Our rock bass using the rocky shorelines on the outside by the lake. Are we seeing predation? Are we seeing northern pike, for instance, getting in the carpgate wetlands and using that habitat as intended? Are the carpgates effective? Are they working? And what do the coves look like versus what does the greenway look like in terms of fish populations versus the channel and the estuary itself? Keating channel, are we getting more attraction of animals into the natural channel, or are they in the Keating channel, or what? So plant communities. So, again, success by species and type, we talked about that. Lake level effects on planting success is a big thing. I'm really concerned about that. We know what the lake level effect is in other areas in the DTA, but really interested in seeing how it affects initial plant success. Algal growth, has been a little bit of an issue with some of the cove plantings, so I want to follow that up and think about how it might affect some of the wetlands that we're putting in. Herbivory and the effectiveness of countermeasures. So we've got, bird and goose protection, things like that. Beaver impacts, other animal impacts, muskrats, for instance. Invasive plant colonization, we've got 39, 40, pretty aggressive invasive plants in the Don River system. So how is the system dealing with that, and the efficacy of the countermeasures we're using? And then the impact, again, of people on invasive plant colonization. So the seeds follow the sneakers, basically. And so are we seeing any patterns there in terms of colonization? And lastly, ecologically wise, carbon sequestration has been a monitoring parameter for some of our larger wetland projects in the Northeast of the United States, and as well as nitrogen attenuation in those areas. Whenever we're working in urban rivers, BOD and dissolved oxygen are important parameters. And upstream nutrient inputs, what's going on in the upper watershed and where's that material going. And then lastly, I included something a little bit different. So it's indirectly, has to do with ecology. If we want to keep doing more of this work, it's super important for everybody in the world to understand that, unlike what is often told out there, that environmentalism or saving the planet costs jobs, actually the very opposite of that is the truth, which is that you can't find job creation numbers as high as those for coastal habitat and river restoration projects. Compare coastal habitat projects in the Northeast of the United States at 30 jobs per $1 million spent to typical road at 7, military at 8, and oil and gas jobs at 5. There's really no comparison there. And so, yes, we have the intrinsic value of nature in urban areas, but these kinds of projects benefit everybody and they create tons and tons of jobs too. So I hope that stimulates the juices a little bit and gives you some ideas, but I guess Jonathan and I can happy to take any questions. Should I stop sharing now?
Yeah, that's great. Thanks so much, Marty. That was an excellent presentation, and I think lots of good stuff to dig into there, and an important reminder about the economic benefits of ecological restoration as well. Thank you. And now I think we're going to pass it over to Angela Wallace from the TRCA, who's also going to give us a bit of a presentation. And then following that, we'll go through the questions. There have been some questions coming through in the chat. Thanks for posting those, and continue to keep those coming. We're looking forward to a lively discussion following the presentation. So over to you, Angela.
Okay, can you see my screen now? It looks like your screen.
It looks like, yes, it does. It looks familiar. So yes.
Yes, it's a little bit tricky. I just realized that. I just copied and pasted your slide. Hopefully we'll get to my next slide. So
there we go. Yeah.
As Shannon said, my name is Angela Wallace, and I work in the Aquatic Monitoring and Management team at TRCA. So you'll see that this presentation is highly skewed towards the aquatic side of things, but we do also have terrestrial monitoring. I do touch on it, but if you have any questions about that sort of work, I can take those back to our team and we can get you some answers on that. So just in case you're not familiar with what a conservation authority is, there's actually 36 conservation authorities in Ontario, and they were created about 60 years ago to safeguard and enhance the health and well-being of watershed communities through the protection and restoration of the natural environment. So we do, our work is focused on the natural environment, and this Don River project is one that's, really near and dear to our hearts, because the Don River itself has been, there's a 90-degree angle in the Don River. It's not natural anymore. So anything we can do to sort of fix that, Waterfront Toronto has, taken this project on, and it's a huge infrastructure project. So just so you're aware, we are actually responsible for 9 watersheds, the TRCA. So that goes from Etobicoke all the way to the Crothers, and this project is sort of right in the center of our jurisdiction. And so we're responsible for all the watersheds as well as the shoreline along Lake Ontario. So what's my role in the Portlands project? My specific role is related to environmental assessment monitoring and compliance monitoring related to fisheries. So for the environmental assessment monitoring, I have 2 different roles. One is related strictly to the EA. So every year we write a report that says, did we do what we were supposed to do, and is the project on track? So it's sort of the regulatory the Ministry of the Environment know how everything is going with the project. But the part that I enjoy much more is the biophysical monitoring. So that is monitoring for baseline conditions and performance monitoring. So we have to make sure that some of the things that, or not some of them, all of the things that we said we would do in the environmental assessment, that we do them, and we do them right. So there will be monitoring for those specific measures as part of this project. The other thing that we help Waterfront Toronto with is our Fisheries Act authorization monitoring. And so when you create any sort of fish habitat in Canada, you need to actually make sure that the fish habitat that you say you're going to make is performing and is effective. So we do some of the monitoring to help with that project. Oh, that slide was supposed to be hidden, but it's still there. So our team has a variety of scientists, biologists, and technicians that deliver a variety of programs. And my presentation is going to be more on this type of data that we have, because I know that this group is interested in the data that TRCA has available already. There will be, a wealth of data available from before, but then a whole other set of data available for after the river mouth opens. So some quick stats, and these are already well out of date. We have over 18 million data records collected, and that's through instruments and manually. We have over 1,900 we have 1,900 monitoring sites, not just water, it's water and terrestrial and different things. We use over 428 different monitoring instruments, and we have 156,000 biodiversity records. And that number has just gone up in the last 2 years. Every year that number increases by quite an amount. So some of the things that we monitor are water quality. And for the Don River specifically, the yellow buoy that you see floating in sort of the middle of that those pictures, that contains a multi-parameter sonde, and that YSI will be going back into the water in a couple weeks. And so that sits right now in the Keating Channel for as soon as it sort of ices out until November, and there'll be a series of those after the new channel is open. So there's that type of data collects everything from pH, dissolved oxygen, turbidity, conductivity, and so it collects that on a fairly regular basis, sort of once every 15 minutes, and records that. So we have lots of water quality data that will be available for the Don River. We also collect information on fish communities and habitat. So our main way of collecting samples right now in the Don River is electrofishing. So if you're not familiar with it, we put electricity into the water, which causes the fish to swim in line with those electrodes that are sort of hanging off the front of the boat, and staff collect them in a net. Put them into a live well in the back of the boat, and we count and measure and identify all the fish that we collect. I'll see if our newest little addition, I'll play this while we're going. Hopefully there's no music. It had music. I tried to mute it, so I apologize if it's there. But we have this new little toy here that's an underwater drone, and this has actually proved to be, really invaluable because it helps us look at what's in the water. And so this is a new tool for us that we're using. So it's not your typical type of data that has numbers in a database, but we were actually finding this really, really valuable. Oh, now we're stuck in a loop. We also do sediment sampling in that area, and so that includes it's surficial sediment sampling, where we do chemical analysis on the sampling. Sometimes we do grain size analysis, and we also look for what types of invertebrates live in the sediment. There's hydrology and precipitation. So there's a flow station that's located sort of in the north, just north of the site right now, but there will be additional flow monitoring done as part of the new channel. There will also be precipitation monitoring done as in that area. And here's my one terrestrial slide. So we do monitor plants and animals, flora and fauna. We do have some interesting ways of monitoring things like bat detectors that we put in trees. And so some of the things that Marty talked about, knowing if the things that they designed is actually working is one of the exciting parts of the project from the monitoring side of things. We also do some interesting research projects that create data. So on the right, there's a picture of someone inserting a telemetry transponder into a fish. And so we, through DFO, we track fish and their location in the harbor. And it'll be really interesting to see where these fish go once that the new river mouth is open. We have other smaller projects like tagging trash in the harbor with UFT, where UFT will be putting in bottles with GPS trackers in them. So, we do a lot of monitoring ourselves, but we also partner up with, a lot of universities and various places to get additional information on top of the information that we already gather. So there's quite a bit of data for the Toronto Harbor and for the Don River itself. So some of the things that we don't sample, which we actually get this question quite a bit. So we don't sample drinking water quality. That's done by municipalities. We don't sample water quality for recreational use. So like E. coli in a beach, that is also done by municipalities. We don't do any emerging contaminants or pesticides, sort of, new contaminants or rare earth metals or that sort of thing. We use only fairly standard conventional water quality sampling. So if it is something that people are interested in, emerging contaminants, that's not something that we have data for. We also don't track down point sources of pollution. So we don't sort of figure out where the pollution comes from. We sort of know it's there, but that's not part of our role, is to track down where it's from. And a question I actually just got today was, do we sample mussels? And we don't. We'd like to, and we'd like to have a better handle on what mussels are in our river systems, but it's not something we typically sample as part of our routine monitoring. So how do we actually use this data? And I just thought I'd throw in a case study, because one of the things we do is we look at how this work is actually, how all this habitat is actually working. And so the Cherry Street Lakefill project was a project where it's a smaller project as part of this Portland's project, where they had to fill in part of the land and or fill in part of the water to create new land. And so if we go to the next slide, they filled in all of this area, and this is where they created the coves that Marty was talking about. So there's some coves that are created specifically for fish. So Marty's team, helped design these coves and what kind of sediment is there and the woody debris. And, we've gone in to sample them to see sort of what's living in there. And this is just an example of one of the coves that has these are carp gates. These gates are meant to exclude large carp from getting into the cove. They do allow smaller fish and sort of thinner bodied fish to get through into the coves. And so we've already, oh no, sorry, we're gonna skip that one. It's got my voice from, I did steal slides from another presentation. I didn't realize my voice was still attached to it. So we've already found 7 species in that cove that I just showed you, which is great news after 1 year of those coves being built. So that's sort of showing the success of the project, which this is only a small little piece of this giant Portland's project. So it's great to see that some of the stuff that's already happening is showing improvement to the fish habitat that's there. So 2 of the questions that were posed to me were, what data are we collecting that I think people would be interested in? And obviously you can see my bias is a little bit towards the aquatic side. So, for me, fish is always interesting because a lot of people don't even know we have fish in the Toronto Harbor. So because it's really hard to see fish because they're underwater, they're really hidden. So anything that can kind of bring light to aquatic organisms that live in the Toronto Harbor, I think would help people understand that it's a really valuable natural habitat. And then one of the other thing was, what would you like to know about how the PLFP project is performing in 25 years. And so I'm actually a stakeholder in this project, being that I live in the Don Valley and I can bike to this site. So, I really hope that in 25 years that I'm able to see, really lush natural environment with birds and bees and butterflies and that sort of thing. And where, it's quite impervious, and there's a lot of hardened areas down there. And so anything where there's some greenery and some life will be, it's a great idea to have. And we're really looking forward to this project sort of finishing up so that we can see that all the hard work that Waterfront Toronto and its contractors and staff have put into it. So that's it from me. If you have any questions, let me know.
That's great, Angela. Thanks so much. It's a really exciting presentation. Thanks for sharing some of the great work that TRCA is doing, and just reminding us all how important conservation authorities are. And I think also a really interesting point about, this data having the potential to make visible what's not necessarily visible in terms of systems or organisms that are in our everyday urban environments that we're not necessarily aware of. So thanks for that. So we are collecting questions, and then there's a few in the chat. Thanks for contributing those, and we'll go through them now. So a couple of themes have emerged in those questions. The first question is, how and where is sediment being removed upstream? And so there is quite a story to the sediment, as Marty alluded to at the beginning of his presentation. Of course, this used to be the site of the largest freshwater marsh in the Great Lakes system, and as part of that riverine cycle, sediment plays a big part. I don't know. I know this is not necessarily right in the wheelhouse of either Marty or Jonathan, but if either one of you feels comfortable talking a little bit more about that process, that would be
Sure,
great.
I can talk about it, Shannon.
Thanks, Jonathan.
And I think it ties into Matthew's question as well, relative to the dredging question about the keating and how that's going to be managed going forward. So this, like Shannon said, this is a little beyond what we are involved with from Interfluve. It's a very large project team that's working on this, and one of the key elements is they are going to have sediment being collected upstream from the Lakeshore Bridge. So there's going to be a sediment collection zone, we could say, of the river, where they're going to be collecting primarily bed load in the channel, but the material that is currently being conveyed all the way into the keating will be attempted to be collected, not just attempted, will be collected upstream of the Lakeshore Bridge in large part. And so we are looking at significantly reduced sediment loading to both the keating channel as well as the natural channel, so that dredging is not anticipated for either of those systems. And we've not designed the natural channel for continued dredging to achieve the depths that we anticipate. That said, kind of a more sciencey note, and Marty can add to this, is that the channel is oversized to accommodate our design flood event. That's the design around the channel was in large part dictated by the minimizing the flooding on the portlands. And so we do anticipate some aggradation of sediment in those channel areas, which will be washed out when we get a big flood. That's the point of that, is that they would wash downstream and the channel would accommodate the additional water. But we are going to see some sediment aggrading within the channel on the bars and potentially reducing some of the depths through the pools. And so we are curious to see how those evolve, as Marty indicated, and that'll be dictated in part by what type of rainstorm and flood events we see in the Don River. So there will be some interesting elements to quantify as we see the channel progress over time. Anything to add to that, Marty?
No, that's pretty good.
Thanks for that, Jonathan. And as you noted, the next question talks about dredging, and I think that I wasn't part of the first session, which touched on the environmental and the geotechnical parts of this project, but of course that's something that's a huge part of the project, that all of the area that's referred to as the Portlands is impacted because it was a historically industrial area. And so there are varying levels of contaminants across the Portland's flood protection site. And for that reason, the river has to be separated from, physically separated from those impacted soils. So there are cutoff walls that have been constructed. And of course, we don't want dredging activities to disrupt the river and, possibly disrupt those layers that are beneath the river, protecting it from those impacted soils. So next question is, will there be any introductions of animals, or are you expecting the animals to just move in, set up shop, make their own houses? Maybe Marty, you can speak to this.
Yeah, there are no introductions of animals planned. We're fully expecting them to start recolonizing, and I know I've heard stories about animals already out there. So we've just begun construction. So we expect them to, a lot of the animals in the GTA are generalists. We're not finding endangered species out there, but so we fully expect them to hopefully, preferably colonize the area. Yep.
Yeah, thanks, Marty. There's, I think, at least one coyote that calls the Portlands home already. Right. So yeah,
I've heard otters are swimming around out there too. So
yeah. So it'll be pretty amazing when the river is finished, I think, to see what moves in, and probably fairly quickly as well.
Mm-hmm.
All right, great. So the next question is, are there countermeasures already planned for control of invasives, or is that something that will be addressed as needed in the future? And maybe Marty, you can speak to the countermeasures that are in the plan, and then Angela, if you would like to follow up just with maybe some information about what the TRCA gets involved with or does not get involved with, maybe as well in terms of invasive species.
Yeah, so the contractor has a contractual responsibility to control invasives and ensure that the native plantings are establishing for the first couple of years. And then after that, their responsibility goes away, and then it would switch over to TRCA. So.
Yeah, and Angela, I know there has been a lot of conversation with the TRCA because, of course, invasive species management is something that's a huge job and just way too big for for any organization to take on its own. So there's definitely a prioritization in terms of the work that has to be done in terms of invasive species management. Moving forward, I think the TRCA would probably look at this and, through the monitoring, look to see how things are performing. And obviously, if something got way out of whack, then an intervention would be required.
Yeah, and from the terrestrial side of things, we've already started, even though the contractors have, a contractual agreement that they have to gone in just to sort of double check to see what's there that's been already planted, and we have one of the best botanists around in this area, and so he can pick up things when they're quite small, and he's already let them know of a few things that needed to be moved and that sort of thing. So by finding these things really early, we're hoping that the rest of the plants that are planted will, establish really well, and that will help to keep the invasive species out from our terrestrial side of things. But it will take monitoring between both the city and TRCA to sort of just keep our eye on it from a terrestrial side of things. From an aquatic side of things, some of the measures are already there, trying to keep carp out of these coves by building these carp gates. And, carp make a mess of things by, rooting around with their snouts and sort of getting all the sediment all worked up. And so other fish can't really use that area and the plants don't grow. And so some of those measures are already in place, and we'll continue monitoring to make sure that, those types of ways of doing things with the carp gates that the carp aren't getting in. So we've sampled quite a few times in the last already in just those in the one little enclosed cove, and we haven't found any carp, which is great news. So we'll keep our eyes open for them, but fingers crossed that, the carp gates do allow small carp to get in, but we also hope those small carp leave and go back out. So it's really the big ones that do the most damage, and they shouldn't be able to fit through those carp gates.
Yeah, we do want some species to move in and establish their homes, but some of them are maybe less desirable, and we hope that they don't stay.
Absolutely.
Thanks, guys. All right, so next question is, will the future coves and bayments on the New Dawn River also have those 2-meter wide carp gates? And I think, Angela, you've just talked about the carp gates in the cove and the important function that they've got. Maybe Jonathan, do you want to talk about the carp gates that we've got in the river
The short
proper?
answer is yes. The short answer is yes, and maybe some more color to that is that it's interesting. We're going to have 4 different wetland areas within the New Dawn Valley, and the difference though is that the carp gate on the West Cove and the Cherry Street Lakeville, we've got 2 gates there actually, so you got some potential movement of the inner harbor water through there in a different way. The wetlands within the Don River will have single carp gates attached to the river, so that's another element that we're going to be looking at. We've got some obviously stormwater runoff that'll be directed in certain areas after being treated, but also just terrestrial runoff that'll impact those wetlands. So we've got a slightly different dynamic in those wetland areas, and as Marty talked about the algal growth, we're going to be watching that. We do expect to see some of that with newly flooded sediment having more nutrients available to that sort of activity, but the wetlands will all be blocked off by carp gates, so we're hoping for, as Angela said, good success on keeping the larger carp out, which create the most harm.
Great, thanks, Jonathan. All right, any more questions from anybody? That takes care of all the questions that we've got in the chat. One last call for questions, and as I said, if you think of questions after this, it always seems to happen to me once the presentation is over and the call is done, then I think of that question that I really wish that I had asked. So have no fear. Again, you can send in your questions to us via email. We will be recording all the questions and providing answers out through the website. So that will be, there's one coming in. Thanks for that one, Lynn. So question, will there be a volunteer stewardship group to assist with the invasive controls? That is a good question, and something that I think that everybody is interested in, but we don't have an answer to yet. So certainly the city and the TRCA are in discussions about how this whole landscape will be cared for in the future, how it will be maintained, and that the part for volunteers to play in that is certainly something that is being contemplated, and I think will evolve as this landscape does as well. We know that there are certainly other places in the city where volunteer stewardship is very valued, and so I think there are opportunities certainly for that in the Portlands as well.
I would just have a quick comment, Shannon. I'd be remiss if I didn't say thank you both to Waterfront Toronto for letting us work on this project, as well as we appreciate our partnership with TRCA. And then our consulting team includes Michael Van Valkenburg and Associates, which is, they've been instrumental in allowing us to work on this, and Limnotech has been doing a lot of the sediment modeling and hydraulics. So it's been I want to definitely recognize that there's been a very broad team associated with this, and so a lot of collaboration, which we've appreciated. So thank you.
Yeah, thank you, Jonathan. It has been heroic effort on everybody's part, and certainly a lot of collaboration. I don't think that this could have been done without really close collaboration, and we certainly appreciate all of the consulting team and their efforts, as well as our partners, TRCA. And we should also thank RBC for the grant that allows for this work to be done, which I think will add just another layer of richness to the data and to the information that we're collecting as well. So it's great.